Hi, my name is Patrik and I want to tell you how to cut embodied carbon in structures. I'm a structural engineer and we have a huge responsibility, but also a big positive impact if you make things better. Why? Because we are the largest user of materials in all industry. So let's start our journey into circular structural design. In March 2020, the European Commission drafted the circular economy package in the context of the EU taxonomy. Hereby, ambitious goals for the use of reused components, recycled materials, and sustainable renewable materials were defined. This will become active in 2023, and if the project shall be classified as sustainable, then that has to fulfill these rules. In the past, the focus was on the evaluation of operational energy use and its related costs. Nowadays, with issues like CO2 tax, the embedded carbon are getting increasingly more important and also relevant in various sustainability certification systems, such as DGNB in Germany or BREEAM in the UK. While energy delivered by the sun is in practice available unlimited, natural resources such as ore or sand for building materials like steel or concrete are limited and becoming more and more scarce. This leads to increasing material prices and the possibility of reusing components or materials and alternative building materials becomes more and more important. Just 3 weeks ago, I attended the Expo Real in Munich, a large real estate trade fair, and more or less every exhibition booth had some kind of logo or link to ESG criteria, environment, social, and governance. I think taking over this responsibility is not only important to attract clients, but also attract future employees. There are many scientific, societal, and political initiatives which define the framework for our activities. Paris Climate Agreement, the European Bauhaus, IPCC reports, the EU taxonomy, and of course the SDGs by the United Nations. They and many more will be an important driver to push our joint activities towards a better future. But reality looks like this: lack of time in the planning process, cutting costs at the wrong ends, missing collaboration between different stakeholders in the industry leads to a lot of over-design of structural elements. Here I see a huge potential to reduce mass and embodied energy, which should be used in the future. I'm convinced that the concept of a circular economy can help us a lot to develop better solutions for the future. On the one side is the biological cycle, but I want to start with the technical one, mainly by reusing structural elements in the future. It is about recycling, refurbishing, reusing, and many more. This is my favorite circular structural design project. It is Eindhoven train station, where I pass by regularly. Here the roof is made out of steel trusses from military bridges from the Second World War. They were not used afterwards and then implemented into the roof. At that time, nobody called it circular structural design, but actually it was. Even if the idea of reuse is not new, today construction industry is responsible for the largest amount of waste of all industries all over the world. But there are many possibilities to improve this. That is why I'm not only practicing, but also working in academia to bring things forward. Now I want to share some research projects with you. Recreate is an EU-funded project with partners from the Netherlands, Germany, Sweden, Croatia, and led by Finland. The goal is to explore the potential reuse of precast concrete elements. Here we study the full process and value chain of the project, which will end in 4 real pilot projects in the year 2025. Starting from the deconstruction process, we are also doing the quality management, the assessment of the current state of the materials and components, develop logistic concepts, preparing an inventory of the available elements, as well as a full life cycle assessment, and inventing new business models to make it viable in the future. But for me as a structural designer, the most interesting part is then the actual design of the new structure and building, because this process is upside down compared to the traditional one. Instead of making elements to measure to fit the design, we have to work with predefined elements and organize them in a way to suit the new design requirements. Here you can see the results from the first pilot project from our Swedish partners, which was shown at the Expo 2022 in Helsingborg, Sweden. Obviously, it looks different to traditional pavilion designs, but great to see that it actually happens and that the pilot projects in the Netherlands, Germany, and Finland will follow soon. Let's move on with the biological circle. Here, obviously, timber plays an important role, but it's not the only possible material for structural elements. At Eindhoven University, we started the research about bio-based composite materials using hemp and flax fibers in combination with bio-based resins some years ago. In 2016, we could realize the first bio-based composite bridge on the campus of the university, which was a great achievement with TU Delft, University of Applied Sciences Breda, and NPSP as industrial partner. The bridge has a span of 14 meters and can carry load of 500 kilograms per square meter. The bridge stayed there for 5 years and now is back in our lab for some more future research and testing. Based on that, in 2020, we could start a large European Interreg project with partners from Netherlands, Germany, France, and Belgium. And in that context, we design and realize 3 more bridges in Almere this year and in Ulm and Bergen-op-Zoom in the Netherlands next year again. Of course, we did intensive analysis with our PhD students and testing in the lab, but in addition, the authorities also requested a full-scale load test with 500 kilograms per square meter according to the Eurocode. Of course, the bridge passed the test, but also the predicted strains and deformations of the structure matched very well with reality. In April this year, we could install the bridge in Almere, where over the summer, the Floriade, an international garden exhibition, took place, and many visitors could walk over the bridge. In the meantime, we are in the middle of the design process of the bridge in Ulm and looking forward to its implementation in spring 2023. I hope I could give you a brief overview of what we mean with circular structural design. On the one hand side, we can try to reuse materials, building components, and whole buildings. But of course, we can also explore new materials such as bio-based composites. So let's achieve truly innovative, sustainable solutions for the future. Thank you.